So the trig we've talked about so far, when we've done problems where you're looking for missing sides or missing angles, has all been with right triangles, okay? And with right triangles, you just use very straightforward SOHCAHTOA. This is what you use when it's not a right triangle. Okay, so now here's what happens, is after I teach this lesson, because this is the most recent thing in your mind, this is what you want to use on everything. Okay, and this isn't really what you want to use on everything. But I'll give you a nice, happy right triangle, and you'll try using one of these, and it's going to get really complicated. Okay? When it's a right triangle, you just use regular SOHCAHTOA. When it's not a right triangle, that's when you use these laws. And so the law of sines is different than just sine. The law of cosines is different than regular cosine. Okay? So we're going to start with law of sines first, because law of sines is probably the easier of the two. Something to keep in mind for both of these types, or both of these laws, is the way you label a triangle. Okay? When you're labeling a triangle, the capital letters represent the angles. So notice at all the corners you have capital letters. And then the sides that are across from them, we name them with the same letter but a lowercase. So across from angle B is side B. Across from angle A is side A, and so on. So when I'm talking about side A, I'm talking about the side that's across from angle A. Okay, that's going to be important. The law of sines looks like this. It looks like a proportion. And so what you can do is you can take an angle and a side that are across from each other, take the sine of the angle, set it up like a fraction, and then cross-multiply it with another pair. Okay? So let's try and do that. So looking at this, where do you see a completed pair, meaning you have an angle and a side? Where do you have an angle and a side across from each other?
78.
Okay, so if I wanted a completed pair where I knew both values, I have the 78 that goes with the 12, right? Where do you have a pair that's like half complete? Yeah, the C and the 32. So I could use those two sets to make a proportion. And I'm going to set that up like this. I'm going to say sine of 78 over 12 would be equal to sine of 32 over C. Everyone okay with that setup? Okay. Now from here, you could actually do sine of 78 and sine of 32 in your calculator, get yourself a couple of decimals, and then do the cross multiplying with the decimals. Or I'm going to show you a way that you could type it into your calculator all in one shot. When you have a proportion, like, I'm going to make up an easier one. 2 over 7 equals 5 over x. How do you solve that?
2 times x.
Okay. So you would do 7 times 5 equals 2 times x, right?
Multiply and divide.
Is there a shortcut? Kind of like you're still doing the same thing, but Sean?
Could you do 7 times 5 divided by 2?
There you go. So we could do 5 times 7 and then divide by the 2, and that gives us x. It's really the same thing as writing it out in the equation. It's just not writing that step in between. That's what I would recommend doing for these. Okay, you could write it out as an equation if you wanted to, but I would actually just do this. I would do 12 times the sine of 32 and then divide by the sine of 78. And here's what that's going to look like in your calculator. You would say 12 times sine 32. And when you hit sine, it's going to open a parenthesis. So when you type in that 32, just make sure that you close the parenthesis after that before you hit divided by sine 78. Yep. And so that equals C. So C equals 6.5. Anyone have trouble typing that in anywhere? Good? Okay. The next example we're going to do, you can go to the next example. It looks just like this one, but we're going to find B now instead of C. Okay? So I still have my one completed pair. I have my 78 with my 12. But now the problem is when I go to find B, what am I missing? I don't have the angle measure that goes with it, right? So I have two things here in this pair that I don't know. And that's not going to work because you can't solve. What's that, Joe?
You can get one.
How?
The angles equals something.
Yep.
Not sure what it equals, but you add them up.
Sean? Okay, the angles in a triangle equal 180, right? So even though you don't have this angle, you could find it pretty easily. And by easily, I mean you still have to do some math, but no trig. Okay? So I would do 180 minus 78 and 32. Okay, and I think you get 70 degrees then for that x. So really this x is 70 degrees. And now I can set up my fraction just like before. So I'm going to say sine 78 over 12 equals, what would my other one look like? Okay, sine 70 over b. And then let's plug that in just like you did the other one. So I would do 12 times the sine of 70 divided by sine 78. So I did this and then divided by sine 78. And I want to say you get like 11.5. Okay, not bad, right? Good so far? Okay, I want you to find some space somewhere. Maybe on like the title slide of these notes, because there's one example for law of sines that I didn't cover in these notes, and I want to make sure I throw it in there. So somewhere in these notes, find yourself some space that you could write this down. Title slide, you could go onto another page, just somewhere where you can through this one with me. I'm going to make up some numbers here. Okay, so let's say this is 36 degrees. And this has a side length of 12. And this has a side length of 17. And I want to know this angle. Okay? So sketch that picture for yourself someplace. Do you see that I still have a completed pair?
Yep.
Where? Which two
You have
numbers?
sine 36 and 12.
Okay.
And then you have
So I can put the 36 and the 12 together. I can say sine 36 over 12. Equals, yep. Now keep in mind that x is your angle measure. So you still want to do sine of that. So sine of x over 17. And then I'm going to cross multiply like I did before. So I'm going to do 17 times the sine of 36. And this time I'll just be dividing by 12. Whoops, parenthesis divided by 12.
And then you just take that and put it into sinus for it.
Good. Yeah, because what happens here that throws people off is here's what you get as an answer. 0.8327. Is that your final answer?
No.
No. Okay, and hopefully when you get that answer, you're thinking, I don't think that's right. I don't think that's my final answer. What that is that's equal to what's left over here. That's equal to sine of x. So when you have this, 0.8327 equals sine x, how do you get back to the angle? Inverse, yeah. So you're going to type in sine -1 of 0.8327. And I get like 56 degrees. Okay, so using law of sines when you're looking for the angle is only a little different because when you do your cross multiplying and dividing, you're going to come out with a decimal, and then you can do inverse sine to get your angle. Okay with that? Okay, let's go to law of cosines. Law of cosines looks scarier, right?
Oh.
It's not too terrible, but that same system still works with the angles are the capital letters, the lowercase letters are the sides. Now, you see here, I just have the one equation. If you were to ever look this up in like a textbook, or even if you were to look it up online, they're probably going to give you 3 different equations. One that starts with an A, one that starts with a B, one that starts with a C. They're all the same equation. It's just different arrangements of how the letters are arranged within the equation. I just focus on one. Okay, it's way too confusing to have 3 different ones and have to pick between the 3. So I just use this one. And then I use this rule down here. whatever you're missing, call that A. So if you're missing a side length, you call that side A. If you're missing an angle, you call that angle A. Okay? And sometimes what's going to happen is I'm going to give you an assignment where the letters are already on there for you, and you have to just disregard. You just have to ignore the letters that are there and put your own letters on it so that it works with this formula. So let's start by finding x. Except we're not going to call it x. We're going to call it A. So this is going to be side length A. Which makes what angle A? Okay, so the angle across from side A is going to be angle A. And then B and C are just my other two. Okay, B and C are just my other two. It doesn't matter which is which. I'm going to rewrite that formula for you real quick so that you can see how I'm filling this in. Formula looks like this. A squared equals B squared plus C squared minus 2BC cosine A. Now, I don't know what A is. I don't have anything to fill in for that A value, so I'm going to just leave that as A squared. B and C are my 15 and my 8. And again, it doesn't matter which order you put those in. So I would say 15 squared plus 8 squared minus 2 times 15 times 8 times cosine of 48. Now, that looks confusing, right? But this is all numbers. Well, I wouldn't even simplify. Since there's no variables here, there's no x's or anything, I'm just going to plug all of that into my calculator. When you have this A by itself over here, this makes life really easy because you can just type that straight in. I think you get like 128. Let me know if I'm wrong. Is that right? 128.4? Okay. What is that still equal to on the left side? What goes here? A squared, right? Don't I still have A squared up here? So am I done?
Nope.
Do I have what A equals?
Root.
Square root. Good. Square root, square root. I end up with A equal to about 11.3. Okay? So even though it looks more complicated, not a lot harder with law of cosines, right? Questions on that at all? Okay, one more, and this one can be a little bit complicated, okay? So this next example I'm going to do is probably the hardest one you're going to...
Today in our homework?
You will.
Oh,
Yep.
Yeesh.
I'll build you up to it slowly. Okay, so this time we're going to find angle Y. But I'm not going to call it angle Y. What am I going to call it? Okay, so this is now angle A, which makes this 15 side length A. Okay, because it's across from it. And then these other two would be my B and my C. Now this is a problem that I don't have this side length, except I do. Didn't we just solve for that X? So that's not X anymore. That's 11.3 now. Okay. Now this time I do have a number for little a. Remember last time little a was what I was trying to find, so I left that just as an a. Okay, this time I don't have a number. So I would say 15 squared equals 11.3 squared plus 8 squared minus 2 times 11.3 times 8 times, and since I don't know the angle this time, I'm going to say cosine A. Now, you're going to be tempted to type all of this into your calculator because of what we just did, but we can't this time. And I'm going to take you to an easier equation. Let's say I gave you 20 equals 4 plus 8 minus 3x. Could I type into my calculator 4 plus 8 minus 3?
Mm-hmm.
Hold on. Look here. Right here, could I, if I was going to solve this, could I just combine the 4 plus 8 minus 3?
Oh, wait, no.
Why not?
No, because there's an X.
Okay, the 3 has an x on it, right? I could combine the 4 and the 8. but I can't combine it with the 3x. Does that make sense?
Yeah.
Okay, so look at this one. I have that same kind of thing going on. It looks a little more complicated, but these numbers here, starting with the 2, the 11.3, the 8, are all attached to cosine of A. So I can't combine those with these over here. It's like there's a wall right where that minus sign is. So I'm going to do this in pieces, and I would recommend you kind of mark down what my pieces are that I'm doing so that you can find them later. So first I'm going to do 15 squared. And for 15 squared, I get 225. Then I'm going to do 11.3 squared plus 8 squared. I'm totally going off of memory here. Let me know if I'm wrong. I think that's it. And then I'm going to go ahead and multiply the 2, the 11.3, and the 8, but I'm not going to combine it with that 191. Okay, again, you're kind of imagining a wall right here. Was I right about that 191? Thank you. Is this 180.8? Somebody check me. Make sure I'm not wrong. Thank you. So that 180 is still attached to the cosine of A. So I can't do anything with it yet. So let's go back to our easy equation. In our easy equation, if I took 4 plus 8 and combined it and got 12, I would then have 20 equals 12 minus 3x. What would you do with it from here?
Divide.
No, you wouldn't.
Subtract.
Subtract what?
What? Whoa, wait, hold on.
You would subtract this 12, wouldn't you? Because that's the one that doesn't have the x on it. It's backwards from how you usually see it, but I would subtract 12 and subtract 12. Right? Does that make sense?
Yeah.
Okay. So what am I going to do here?
Subtract 191.
Okay, so let's subtract the 191.69. I get 33.31. Equals negative, and right there, that negative sign, that was part of the original formula. Remember that formula has like minus 2bc in it? So this number that's left over here is always going to have this negative sign on it. Okay, the number that's left there is always going to be negative. Now what? And if you're not sure, look back at this. What would you do here?
Divide.
You would divide, right? So what am I going to do?
Divide.
Divide by, okay, the negative 180.8. Okay, and I get 0.18, oh, I get negative. Negative 0.1842. And now that equals cosine A. Okay? Now what? Sean? Yeah, I'm looking for the angle, right? So I'm going to do inverse cosine. I'm going to do cosine negative 1 of negative 0.1842. And I get like 100.6 degrees. Okay?
That makes sense.
Good? Now that one's a little more complicated, right? Like the process, but if you break it down in those 3 chunks, then it's just equation solving. Okay? Think you can handle a few of those today?
I guess.
I guess. Awesome.